This video, we're going to talk about the graph of secant and transformations of that graph. I'm again going to just be graphing on the Desmos graphing calculator. I want to show you the parent graph of secant first. It's going to have its original cycle from negative pi over 2 to 3 pi over 2. It has asymptotes at negative pi over 2 and at pi over 2, and then at 3 pi over 2, and so on. All the odd multiples of pi over 2, there are asymptotes there because those are the zeros of cosine. So that since secant is 1 over cosine, all the zeros of cosine are there. And I want to show you also, if it helps you to graph it, that y equals cosine of x is going to stay between these parts of the graph of secant, and that the minimum of cosine is going to be this local maximum of secant, and this local maximum of cosine is going to be this local minimum of secant, because when I take the reciprocal of something between 0 and 1, it's going to become greater than 1. When I take the reciprocal of something between 0 and negative 1, it's going to be less than negative 1. So that might be helpful for you to see that. Now, again, we only have a couple examples here. So the first one is going to be a horizontal shift of pi over 5 to the left. So I'm going to get rid of this table here, get rid of that cosine graph, and I'm going to make this secant of x plus pi over 5. And you can see that the secant graph has been shifted 5 units to the left. It now has its minimum there at negative pi over 5, 1. Negative 6 pi over 5, negative 1 there. 4 pi over 5, negative 1. Its asymptotes are going to be shifted as well from pi over 2 to pi over 2 minus pi over 5. So that's going to be five pi minus 2 pi over 10 is 3 pi over 10. And then it's still going to have a period of 2 pi. So 3 pi over 10 is this asymptote that is right here. And then if I were to get to that point in the cycle again over here, it's going to be 2 pi away, but halfway between there, pi radians away. So at 13 pi over 10, there's going to be another one, and so on. All right, I've only got one more example for secant. Most of the graphs in this one are examples of cosecant. So we're going to look at a horizontal shift and a vertical stretch here. 3 secant of x minus pi over 2. Now, if I had shown you the graph of cosecant already, this would look a lot like that graph, because let me show you the work here. This is actually a cosecant graph. 3 secant of x minus pi over 2 is the same thing as 3 secant of negative pi over 2 minus x. Secant is an even function, so the negative goes away. 3 times secant of pi over 2 minus x. This is the definition of a cofunction here. So this becomes 3 cosecant of x. So when we see the graph of cosecant in the next video, you're going to see that that makes sense, that the asymptotes are at 0 and pi. And if I would put the graph of y equals 3 sine of x in here, you would see that it's the reciprocal of that right there, with its minimums of -3 touching the local maximums right there. But this is just a transformation right now to you of the secant graph, and you can see the relationship that because they are co-functions, that things that are secant graphs can be written as cosecant graphs, things that are cosecant graphs can be written as secant graphs. Sorry, I missed my C and my parenthesis ran together there. But that's it for right now. We'll probably have some of the cosecant graphs that will do the same thing with the cofunction identity and turn into secant graphs. So I just wanted to show you a couple examples of this one before we move on and do our examples of cosecant. So there it is. I'll see you for the next video where we talk about the cosecant function, which is the reciprocal of the sine function. All right, see you in the next video.